Now let's talk about section 9.2. We're still working with linear equations. So we have a little bit more going on. So go ahead and read a little bit here if you need to pause the recording. Let's start working on it. All right. So solve this. Let's solve B, okay? We're pretty comfortable with A. If not, let's go ahead, because on the first section before this one, we actually had a coefficient of +1 most of the time. Every now and then you saw something other than that. A has a +3 coefficient. So let's get the variable term by itself, because that's the first thing we're going to do is isolate it. Since 3 here is added to it, we're going to subtract it because we want it to go to 0, right? So what you do to one side, you do to the other. So now I have 3x is equal to -18 minus 3, which gives me -21, right? Because 18 plus 3, basically saying I'm in the whole $18 to spend 3 more. Now we're going to divide by this 3 on the x because we want it to be a +1 coefficient, and that 3 has been multiplied by x, so division will undo it. Now I have x is equal to -21 divided by 3 is -7, because 3 goes into -21 -7 times. Now, if we want to check to make sure we have a true solution, we're going to take our original equation and we're just going to plug in what we found for x. So I got 3 times -7 is -21, plus that 3. Does it equal -18? Yes, it does. So we're good. True solution. Let's solve B. B says we have a +2y minus a -4y. So let's put those two together because they are like terms. If you notice, y both has a power of 1, meaning it is linear. So it says you have $2, you spent 4, so now you're in the hole 2y. Bring down that -14. Now I want the y value by itself, so I'm going to add this 14 to both sides since it's negative, because we want it to go to 0 here. Now I got -2y is equal to, if you have $14, right? You had 14 and you spent 26. Now you're down to, in the hole, $12. Now, y has a -2 coefficient on it. We need it to be +1, so that means I'm going to divide by that -2. I want to rewrite it where y is first, because in math we read left to right in America. So now we say -2 divided by -12. Well, negative divides negative is positive. 2 goes into 12 6 times, and that's my solution. Okay, so let's do F. It's a little bit messier, so let's do it. You notice that we have all of our variable terms here are to the first degree, so they're like terms and it is still linear. I'm going to rewrite it to where they're together because those are the ones that I can put together. And then bring the rest down. Now, in order to add and subtract these and their fractions, we have to have common denominators, right? And I'm looking at my denominators of every one of the terms in here, and I got 2, 4, and 3s. So a number that all 3 of those will go into would be 12, right? So I'm going to multiply every term by 12. Okay. What happens? 2 goes in itself once, goes in 12 6 times. Now I got 6 times that 1, x, gives me 6x. 4 goes in itself once, goes into 12 3 times. And now I got 3 times 3, which is 9x. 3 goes in itself once, goes in 12 4 times. Now I have 4 times that 2x. So it's a -8x. 2 goes in itself once, goes into 12 6 times. Now I have 6 times 5, which is a +30. I have -1 times 12, it's -12. Now let's finish putting all of our like terms together. I got 6 plus 9 minus 8, and that gives me 7. So I got 7x plus 30 is equal to negative 12. This positive 30, let's subtract it from both sides because I want x by itself, and I want the 30 to go to 0. So now I have a negative 12 minus that 30, basically meaning that you're in the whole $12, you spend 30 more. Now we're in a negative 42. I'm going to divide by this 7 on each side because I want a positive 1 coefficient on x. Positive 7 goes into negative 42, negative 6 times. Okay. Let's do example 2 here. It says the tickets for a figure skating performance sold out in 5 hours. If there were 25,000 tickets sold, solve the equation. Well, that makes sense. Why it's set up that way, right? To find the number of tickets sold per hour. So X is going to tell us how many hours it needs to be, find the number of tickets, how many tickets it needs to be sold. Okay, so let's solve for this. If I got 25,000 minus 5x is equal to 0, let's add the 5x to both sides. So now I have 25,000 is equal to a positive 5x, and I need a coefficient of positive 1 on x, so I'm going to divide by 5. So 5 goes into 25,000, right? It goes into it 5,000 times. So that's how many tickets it needs to be sold. The last one says match the example to the steps being used. All right, so if we look at this, what do we have? We have 3/4 y. Whoops, I put x. Sorry, my apologies. 3/4 y is equal to negative 12. All right. There's no adding going on here, so we're not going to say addition principle. There is no like terms here to put together, right? So we're not going to say combining like terms. However, division and multiplication principle does factor. Division of property of equality just says both sides of an equation are divided by a common real number that is not equal to 0. The multiplication one says both sides of the equation are multiplied by the same number, the expression on both sides. So both of these are in play here. One thing we could do is say, hey, let's multiply by the reciprocal on both sides. Well, if I do that, now I got negative times positive is negative. 3 goes itself once, goes in 12 4 times, and I get negative 16. So I multiplied, right? And I reduced. But what if I said, well, let's do y is equal to negative 12. Well, we're going to multiply both sides by 4. That reduces, leaves me 3y is equal to negative 12 times 4 is negative 48. Now let's divide both sides by 3, and I got y is equal to 48 divided by 3, and don't forget negative divide positive, so it's negative 16. So I'm going to say it's true for both C and D because we can work it 2 different ways using just the multiplication and use multiplication and division. Reach out to me if you have any questions.